And I think we're live. Hi, this is Josh, also known as Cpgeek, and today I'm going to be upgrading my Ender 3 to use an SKR E3 Mini or Mini E3 control board. The Ender 3 kind of died a couple of weeks ago. I was plugging in my Raspberry Pi that I used to run octoprint / octopi, which is a really cool web server application that controls 3D printers, pretty much anything running common variety 3D printer firmware from Marlin to Clipper to all kinds of stuff. So really nice overall. Definitely a big fan of that. So looks like I'm dropping out for some reason, or at least that's what YouTube says. Audio stream bitrate 0. That shouldn't be possible, as I clearly have YouTube streaming. Anyway, there's always technical difficulties. So anyhow, I was plugging in my octopi setup to my Ender 3 3D printer, and as I was plugging in, the USB port just broke right off the motherboard, sheared completely off. In fact, hang on for just a moment. I think I still have photos from that catastrophe. Let's go back. All right, so one moment. Yes, here we go. And so this is the board for the Ender 3. And as you see here, this is where the USB port was. Really, really annoying that it's not there currently. And I believe, yep, this is how small that USB port is. It's sitting on top of the standard quarter. As far as overall size goes, that's relatively small. You see here, I was thinking about the possibility of resoldering it with the tools that I have, but this is the slimmest solder that I have, and it is really, really small, and you can see its relationship to the USB ports. It's just about the same width as one of the pins on the port if I wanted to reconnect it. Also, these ports typically have longer connectors. The connectors themselves seem to be broken on the board. And so reattaching this is pretty much a no-go, and getting a new one is pretty much a no-go unless I wanted to invest in some surface mount soldering gear. So these are really, really, really tiny pads. These are about, common through hole soldering holes here. And these are the mount points for the outside, and they just sheared off. I wasn't using excessive force or anything. They just pop off the board. I think that these might be a cold solder. It's really hard to tell. This is my cell phone camera, which is pretty decent, but it's zoomed way in, so it's kind of grainy. Sorry about that. But just to fill the screen with it, there's pretty much no solder on these pads. They're just nothing there. And these, it looks like the metal just popped free, like there was nothing holding them down at all. I did look on some various user groups, and it seems that this is unfortunately a common problem to early revisions of the Ender 3. You'll see here on the side here, this is Creality's version 1.1.2 board. I believe that they're up to 1.3 point something or other, which is a couple of years of revisions. So I just happen to have an early board. I am way out of warranty. I've had this thing for a couple of years, so unfortunately there's nothing much that I can do about that. So, given disaster struck, I will be going ahead and doing an upgrade. And that upgrade that I've chosen is the SKR Mini E3 version 1.2, which is right here in my hand that I was reading from. I'll go ahead and zoom in on that in a couple of seconds. Just switch back and find the close-up view of that. So that is this guy right here, the SKR Mini E3. That's what I was holding up just a moment ago. And this matches pretty much one for one with a few minor exceptions to the Ender 3 board. It even comes pre-flashed with Ender 3 compatible firmware. That is firmware configured with the extents as far as the dimensions, the normal E-steps for the extruder, and the steps for all of the stepper motors pre-configured for the Ender 3. So they just use the factory defaults and all that, which is really cool. So it should be a matter of just plugging this thing in. Couple of cool things about this particular board. This is not an Arduino like the others. This is actually a full-on ARM chip. So this is going to be quite a bit quicker in terms of calculations, in terms of responsiveness, or it should be anyway, compared to the stock Ender 3 board that's in there. Further, under here, these are the 2209 stepper drivers, which have their silent mode enabled in the firmware already by default. So this should hopefully reduce the noise generated by my 3D printer by quite a bit. Further, as you see here, there's a nice 20 amp fuse to protect this thing. I don't believe that the standard board has that, but I'm not completely positive. But also there's a few expansion options on this board that the stock one doesn't have as well. There's a NeoPixel port, which I won't take advantage of, but it's pretty cool. It basically gives you a light setup, so you can have a really bright light next to your hot end if you choose to purchase one of those. I don't have a NeoPixel. I don't think it's an upgrade that I would personally go for, but it's a nice add-on. Down here, you'll note that we have servo control, a separate control for probe, which is great because I will also be upgrading this to, where's the box? I should be slightly more prepared. I'm upgrading this Ender 3 to also use a BL Touch. While the BL Touch firmware is not on the board from the factory, there's a quick, easy, downloadable and flashable version of the firmware pre-built with BL Touch compatibility. So for auto leveling, all I got to do is download it and go. It's also running one of the later versions of Marlin. It's running the 2.0 branch. As this is an ARM processor, it's more than capable of handling it. It has way more memory available to it than the stock Ender boards as well, which is going to be important for adding on extra features like that auto bed leveling. Mesh leveling does take a little bit more RAM in order to store those options and preferences and do the whole mesh leveling calculations and those sorts of things. That should be much quicker, as well as have the space for all of that. So if I choose to down the road use things like linear advance, I can figure that out and add that to this board with no problems whatsoever. From what I understand, these screw terminals here on this side correspond to power in the heater and the thermistors. This is the heated bed. This is the extruder heater. Voltage in and ground for what? I'll have to refer to some documentation. I already have the BigTreeTech, the company that makes this. They have a YouTube video guide that I currently have open. I'm going to be following along, not necessarily with the video. I'm not going to necessarily directly play this, but later in the video, they have some wiring diagram type stuff. Where is it? Oh, there it is. I just had it a second ago. Right in here that I can use to more easily figure out where things go. Um, so DCN power, heated bed, and all various places to plug in things, including the LCD, which is pretty easy. It just kind of works with the Ender. They do sell an LCD kit, which is full color and has graphics mode and that kind of thing. And the ARM is probably enough power to power that as well. But I don't really need a flashy user interface on the printer itself, as I use Octopi pretty much for all my interface needs. In fact, let me go ahead and just pull that up real quick. So this is Octopi, and I know that I have some warnings here because I just printed some stuff off, and there's some updates available. So this is octoprint running on Raspberry Pi 3, running my TiVo Tornado. So you get things like temperature, nice dashboard, full control interfaces. I can control the carriage, so X, Y, Z. I can extrude. I can do bed leveling from here. I can store prints that I have on an SD card. All this stuff is really great. I'm pretty sure that I've showed some of this off in previous streams, but it never hurts to go over this again. There's also a huge plugin interface, like this whole bed leveling thing. This is for manual bed leveling, but I just implemented mesh bed leveling with a BL Touch on my Tornado. I did no, I did not do a stream on that one. I just kind of reconfigured it. I ended up rebuilding that printer not too long ago. I will be showing some of that off soon on a future stream, but I decided to forego the streaming for that, as it took me about a week. I ripped the whole thing apart and I put it all back together, and it's now printing great. Anyhow, so this is a nice interface for doing control of 3D printer. It's really nice overall, and I will be using this for both, which is why I was trying to plug it into my Ender 3, following some of the maintenance I did in the previous stream here in this video, and that's what caused the USB port to fail, because it wasn't soldered down correctly. This should be a pretty good board to use. Everything lines up to the same case spots. The SD card, which comes with a small, I believe it's a 32 megabyte card, which is just enough for flashing firmware and maybe doing a couple of default G codes. USB core. The USB port is in exactly the same space, so I should be able to plug that in just fine. But it does have a separate probe input for doing the BL Touch plugin, as well as a separate servo. So this whole area is basically dedicated for BL Touch. These are end stops down here, as well as thermistor. The thermistor for the bed, the thermistor for the hot end, the end stops. Just should be able to plug that in place. The stepper drivers, this board did come with some nice little heat sinks for the stepper motor drivers. I have applied those. As you can see, they're nice blue heat sinks. I wish that they were using better thermal adhesive or thermal epoxy, and that they applied them from the factory. They are a little wobbly after application. Hoping that won't affect their heat dissipation too much. But I do wish that they were a little bit more solidly connected, either via some kind of retention mechanism, or with thermal epoxy, or I'm kind of reluctant to just put heatsink compound on them, as I don't know if under heat and load, if it might become more viscous, and I don't want those heat sinks sliding off while the control box is enclosed in a metal enclosure. The heatsink could slide off and hit an active component shorting the board. That's never good. Or it can become dislodged from the driver itself under load, and it could overheat and kill the driver. Most drivers on most boards are socketed. I actually had the choice of going with this or one of the SKR turbo boards, which are very similarly configured and will work fine with an Ender 3 as well. I chose to get the non-socketed versions that contain the 2209 soldered directly to the board, as you see here. And that's just because I didn't want to have to mess around with sockets and configuration and building firmware for particular stepper drivers. It's not that difficult to configure overall, but this is literally a plug and play situation. Or at least it should be a plug and play situation. I don't mean to count my chickens before they hatch here. So without further ado, that's sort of my background and why I'm doing this. I'm also hoping it'll silence the printer, make it a little quicker. That's why I didn't go with one of the higher revision Creality boards. There are newer versions of this board that are available. The board that failed, not the SKR board. The Creality stock Ender 3 board. There are new versions of that shouldn't have the same failure as this one does. The new version does come with the 2209 silent stepper drivers, just like this board, but that's still running on the old version of the Atmel processor, the 8-bit printer versus the ARM 32-bit printer, which is quite a bit slower and has quite a bit less memory. So I decided to go with this, and we'll see if that's a good choice or not. Further, this did come highly recommended by a couple of various YouTubers. In particular, all right, so that's the guide. So anyway, in particular, there's a YouTuber called Teaching Tech, who has put together a bunch of guides for this. I may be referring to one of his videos as well a little later, just for second opinion in doing the installation if I need to. I've never installed a control board in a 3D printer before, but let's go ahead and do this, I guess. So let me go ahead and jump to the 3D printer itself. So that's the Ender 3 down there, waiting to go on a table right by me. Let's go ahead and bring that up. So there we go. It's a little on the dirty side, but it has a couple of 100 hours printing. So it's gotten used quite a bit. And yeah, so pretty good overall. I have to scoot over here. So we're going to be looking at the side of my head. I haven't quite gotten this set up complete yet in terms of how to get a forward and side camera going on. Get rid of this. Just have to see that camera feed. All right. So the control board is stored in this section. Grab a handy box of 3D printer doodads and look for a screwdriver that will fit this. Big. And it's a little small. Let's see if I can. The appropriate one's got to be in here somewhere. Just air tube it. Getting that whole Goldilocks syndrome going on here right now. just right. Let's put these back in the box here. Kind of lumped all of my 3D printing small tools and Allen wrenches into that one little box for safekeeping, so I don't lose any of the components. All right, so let's get this open. Torque required. All right, so more screws here. Always a good sign. Screw 1. 2. And the third one is way back here. So I'm going to move forward because I know that will actually go past where that screw is. Right back here. This should only have 3 screws in it, so it shouldn't be too hard to pop apart. However, there is 2 sides of this too, so I think that in the video they recommended taking this whole box off the rail. I don't really want to do that. If I can get away with just pulling off the panel here, there we go. Now, well, it looks like things are pretty easy to get at overall. I think that in this case, I'm going to try to connect things as I disconnect them. I think I have enough cabling for that. So here's the new board. Try to reorient this so you guys can be a little bit better in there as well. So there's plenty of space in this control panel, or this control board situation here. I don't think I'm going to have any problem whatsoever. But just trying to move things just a bit. Yeah, I don't think I'm going to have any problems whatsoever getting in and around here. First thing I want to do, and note that this printer is completely unplugged. In fact, it doesn't live in this section at all. Its home is actually in a separate section behind me. I have a little stand area for it, so that it's both out of the way as well as a little bit better protected. I don't have any power running to this. That's the important part. It has been offline for a while. Another note, the power supply is only being held by power supply is only being held by this one screw here. And that's the power supply back here. So it's kind of like, the reason for that is the bottom screw here, which you can't see around the printer right now, is all the threads are bare. The power supply itself, it goes right into the body of the power supply for stability, and being really thin aluminum sheet metal, the threads just pop as soon as I tried to torque it in there. I ended up over torquing it. All the threads for the other bottom screw there. Same thing with the top one, but that screw at least is holding on a little bit. I do want to end up relocating the power supply to the rear lower part of the printer eventually. That's not today's job. Probably be doing a stream about that in the near future, but that's for another time. First off, I think that I want to try to loosen the board from its current location by unscrewing it. Actually, you know what? Let's start. I'm just going to remove the front panel connector. Oh, I see that there's some glue involved here. That's never a good sign. I'm going to have to more than likely start chewing through glue here with probably a knife or something. I do have a hobby knife next to me. That'll probably do the job pretty well. It's just hot glue, it feels like, so it shouldn't really get my way too much. but it is good to know that it's there. And there's also some that was gluing down this cable that I'm holding onto here as well for the front panel, but doesn't appear to actually be connected to this. It was repelling on the jacket of the cable, which isn't a huge deal. It doesn't need to be glued down as far as this cable goes, or really any of these cables. They're all relatively well secured by other means. It appears that all of these have labels. So I don't really care if I kill the ports on the board. I'd like to try to avoid that if I can. Technically, this board still works. You can still print things off of SD cards with it. It just doesn't have a USB port. So let me try to get some of this glue out of the way. Of course, if I cut through one of these cables, it's not going to be a good time for you either. But I also don't want to go yanking on ports all willy-nilly like. Okay, so that's going to be a slight problem. All right. Looks like I've broken through that glue. That end. Some of this glue is pretty stubborn. Just have to, take some care because I need to reuse these connectors and this cabling. And let's see on here. I'm just trying to look at the label here real quick to see what's what. Things, I've been told that things are relatively well labeled. Is that 3? E. That must be the extruder stepper motor, I guess. Yeah, these must be the stepper connectors. Sorry, I'm still learning how things go together myself, so learning as I go. All right, I'm going to try what I did before, just very gently try to cut/pry this glue. And try not to cut myself, the cables, or the motherboard. Those are some pretty big what ifs there. Oh, there we go. Just prying a little bit. Using a little bit of cutting to get purchase and just prying away gently from this connector. It's like I can pull the glue a little bit. Not worried about destroying the glue. I think that came off cleanly. So let's pull this. Okay. Z stepper motor. Okay. Same thing, more annoying glue. I guess they just do this so that when it's in transit in the slow boat from China, that things don't work themselves free. But these connectors are pretty robust. I don't think that they would ever just pop free on their own anyway. They're pressure fit. They're pretty nice JST connectors. Wiggling back and forth a little bit. Gonna break the bond of that glue, which looks like the glue stayed on the board, which I'm fine with too. I'm just gonna pop the glue off. No reason for that to be there. Oop, got a fan. That's never good. There we go. All right. Last stepper motor. Last glue blob on stepper motors anyway. Just trying to use that same technique to not destroy anything, such as the cable, preferably. Let's wiggle this free. Yep, pop right on out. left a little glue behind on the connector. Oh, you can't see that, it's blown out in the image. I think I'm going to turn down the white balance just a bit on this camera that I'm using. It's actually a webcam that I've set up on a tripod. I was hoping that would be a better technique than using NDI on my phone like the previous streams. The quality of the camera should be pretty much on par. A little lower resolution, but it's not too bad. All right, so I want to configure video, and I want to go to one second. It's backlights, white balance. Exposure. There we go. That would be way better, but a little better. I can do slightly better than that. Always a learning experience when I do live streams. Please stand by. A little less exposure. -7. I think that'll do it right there. The image is a little dark, but you're able to see everything. It's very contrasty, a little grainy, but you know, it works, I think. Anyhow, back to it. Oh yes, I was removing glue from this connector here. You can sort of see. There we go. Just trying to get the last little bits so that I can clean these new connectors. All right, that's pretty good. Anything on here? Nope, board's relatively clean. All right, so steppers are out. This side of the board contains end stops and thirsters. So the complicated part is the unlabeled power connectors. So that's the part that I believe I'm going to have most difficulties with in the side here. So on this board, the new SKR board, that would be this section here, these screw terminals, because they're not extremely well labeled. They're well labeled on the board, and they might be labeled on this board. I'll have to read that a little bit. But if they are labeled, they're not labeled labels like these other ones are. So that's super annoying. Oh boy, more glue. Just what I wanted. These cables are a little tighter. Let's see if I can bring it more just a bit. Is it better if I put this on its side? No, I have plenty of slack. Just push it on through. All right. However, there's a cable blade that really prevents splitting cable sections, which is good and bad. It means that it keeps all your cables together and going in the right space, but it's bad in that you can't separate the cables out to sort them easily and put them in the right connectors. So we'll see how that turns out in a couple minutes. Just come in here with a hobby knife so I can try to get rid of some of that glue. It's probably not so much fun to watch at this point. If and when I go back through this, I may edit this part out or make a shorter version. The just the more interesting parts. Future note, if and when I choose to build something with circuit boards and connectors, I know that just a little bit of glue on some JST connectors will make it so that it's pretty much impossible to remove accidentally. Because this whole thing is working out really well for not ever getting these removed. I mean, it's not impossible. It's hot, but it's pretty annoying. Stuff is pretty much in there. There you go. Got one cable almost free. So hot glue's coming with it. Oh, it looks like there's just a strip of hot glue that I can pull off these JST connectors. That's nice. So this whole bunch of hot glue came off, which should help me pull the rest of these cables out. So that's nice and clean. I don't think I damaged any cables or anything in there. Although now I don't know what this is for at all. Okay, so I'm going to make that longer than the rest of them so I know exactly what it is. I think it may be labeled on the board. I think these are the thermistors. So the long one is going to be one, and the short one is going to be another. This one is definitely the fan's lid. And there is a separate note about that in that video. I did watch a video earlier as far as the SKR installation video for the Mini E3 for the Ender 3. These little yellow things, get one in view. These little yellow things, they show up. I think there's some color shifting going on. Show up as white on here. That's not correct. Webcam filters. Webcam properties. Configure video. White balance. Oh. Yeah, white balance. A little closer. Saturation. No. Left back. That's more or less right. Sorry about that. So these are yellow, even though they don't show up clean as yellow on the screen. That's kind of annoying, but that's what I get for using a good webcam. So just like them back on glue. I'll hopefully be upgrading my B camera at some point soon, from a webcam or cell phone NDI solution to a full-fledged mirrorless camera. But in order to do that, I'm going to need a little bit more support from viewers. Really appreciate what I've gotten already. But if you like this kind of content, please do click that donate button below. I really appreciate it. Or just tell your friends about these live streams. And yeah, if you think that this is worth it, please do go ahead and click that donate link and use PayPal to send me a few bucks. That would be awesome. I'd really appreciate that for equipment upgrades. I have a decent 8 camera that I use for talking head stuff, as you saw in the beginning. But that's kind of locked down right now behind my monitors, so it's not easy to move it around for this kind of work. I most often use it for gaming streams over on Twitch, twitch.tv/Cpgeek2 if you want to see me play some video games every so often. I do more of those kinds of streams more than I do these, but I typically dabble with various technology things here once every probably a couple of weeks to a month. I'm hoping to have videos up on this channel at least once a month. So please like, subscribe, and check back in, hit that bell icon, and you'll get a notification when I release new videos. Also, if you have any questions or any comments that you'd like to make, I definitely read them all, so put those down below. I'm always happy to answer comments and interact with folks who are interested in the content that I produce. Just having people watch is awesome. So tell your friends, post to social media, Facebook, Twitter, all that good stuff. This glue is so annoying. I think this is the job right here. Pretty sure it's going to be smooth sailing once I can get all these connectors free and this board out of here. The board is only held down by a couple of standard hex screws, just like the rest of the printer is constructed with. So I doubt it's going to be a hassle. All right, so there's one. It's still stuck. Damn this glue. So ridiculously in there. There we go. Got one. Pull the glue residue cleanly across the next one as well. I think I got a little bit of it. Let's see if the next one will come free. And it has. Awesome. Those are all labeled. All right, this is a separate connector. Looks like it's probably the parts fan because it has separate cables that look a little different than the rest. This is yellow and blue. It occurs to me that I probably should have taken some pictures of this before I started, but I also assume there are a ton of pictures of Ender 3s online. This is one of the most popular 3D printers available due to how inexpensive yet how reliable they are. Everybody and their brother flocked to get an Ender 3 in order to print PPE during these trying times. Is that it? Yep. Okay. There's a little bit of glue on the connector. Let's see if I can pop that free. Is that it? Nope. A little more. I'll leave the glue on the connectors. I know that they're not going to go into their new homes cleanly. Right? So that's the last of the small connectors. So I'm going to try to push the connector blocks back a little bit just so I can get at the board and swap the board out. I know that I still have the screw trim connectors, but those are far less a thing than the others. I also want to see exactly where the screw terminals hook up so I can plug them in the same way on the new SKR board. So without further ado, I'm going to go ahead and undo this board, which is actually held in with the same screws as the box was held down with. Pop out my SD card. I don't even know if that thing works. All of the SD cards that I've received with various printers have failed within a short period of time. I think that they're just going to be really creamy manufacturing processes. Reject NAND. How am I going to get that out? There we go. These are very tiny screws. Further up so you can see. So I think that this is the last screw holding it down, if I'm not mistaken. But this thing is unplugged. Each quarter of this thing to Kingdom Come. All right. So I'm pretty sure this is the last screw, at least holding down the board. Let's see if I can wiggle this guy free, despite the possibility of tape or glue. It doesn't appear to want to move. Did I miss the screw? Held down by glue. I can't tell. But it's not moving. See if what the melt points are on this board and see if I missed a screw. So there's one here, and one here. I got all those. Where else did I miss? 1, 2, 3. Yes. There's one right next to those blocks. Corner. I'll pull this closer to myself here so I can see around. And no, it's actually unpopulated. No screw there. There's a bit of a hole. It might be a through hole for a solder joint or something. It doesn't look like that case on here either. Looks like just the 3 points, and I extracted 3 screws. So, glue. I'm going to try gently prying while trying not to destroy this board. Let's look, moved a little bit. I was able to see. Oh, I did miss a screw. Darn it. Thankfully, the movement of the board showed me where it pivoted. These screws are torqued down really, really tight. Kind of shocked because everything else on this printer is not pokey. It's all secured very well, but it's not overly tight typically. All right, so this board is free and not glued down. Was it ever? No, it was not. Signaling standoffs. That's fine. So I'm going to try to retrieve that screw without unplugging or pulling anything. Come on. It's always something. There we go. Screw. Okay. Now, do I actually have enough slack to pull on this power supply? The answer is not a whole lot. Try to yank up this loom here. Shouldn't hurt any of the cables. Okay. Further. All right, so that's about as much give as I actually get here. Yeah, so that's all she gets. Okay. Screwdriver. I don't have small Phillips other than my auto screwdriver here. Sorry, not Phillips, flathead. Other than my auto screwdriver here. So I'm going to use that. Try in auto first. Won't break anything up. Let me see if I can find the groove. Did it? Open. To get the not enough. One screw. Let's turn the whole thing. Do I have enough work to do that? No. Hope I didn't strip it. That would suck. I can't do Dennis with board mounted. Down a bit. Run this at its slowest speed. That can ruin a tip. Huh. I think it did. It's all chewed up. These are not hardened tips. I know that I have another one that's a little bigger. Or if it's too big. There we go. So what do those connect to? I'm going to take a look at the zoomed in version of this board here. Okay, so it's, oh, they're arranged differently. Let's see, this block has 1, 2, 3, 4, 5, 6, which probably corresponds to 1, 2, 3, 4, 5, 6. And these are Phillips. Hey, where are these Phillips? And that's for E0, the bed here. Now, just looking for reference here real quick. Because I otherwise don't know what those are connected to. Like, honestly, it's probably the bed here, I would imagine. Um, 1.1.2, 1.1.2, Ender 3 board. Just trying to get a picture of it. See if there's actually writing near the block. Okay. So the resolution is from me, but there we go. So yeah, it appears that this is the nozzle, which is E0. So this directly compares with E0 here. So I guess I'm going to try to, like I said before, hook those up as I go. So that means I'm going to need to swap for Phillips tip. There's my flathead tip, Phillips tip. Just here. Screw. And those are totally open. Very much so. Stick these wires in there, squeeze them down. I'm just going to put them in right in the order that they're in now. These are bare wires and not pinned whatsoever. Not great fit finish for something that's should last for a really long time. So start this 1. So, get it in the hole. Not ripping the other connector, because that would totally suck. So this has a magnifying. The other lens popped out. I'm just trying to get a feel for making sure I don't bridge anything here. How to best do this? If it wasn't nearly 4 a.m., nearly 5 a.m., and I hadn't slept, I would probably tin these wires myself with a soldering iron. But because A, they were not installed that way initially, and B, I'm tired and I don't really feel like breaking out a soldering iron right now. I'm going to twist the ends, try to get them in the hole as best as I can, just like that, and then lock things down, just like that. That is not far enough in. Pastes. Get all the way in there. And then yeah. Hopefully that's making enough contact. Yeah, that's in there. Give it a little work. Oop. Going nowhere. Where's it going? Nowhere. I'm going to do the same thing here. And I guess right down the line. It just needs to not touch that other wire, or I am totally screwed. And things start melting down and dying, and maybe fire. I don't want fire, so taking my time here with this a little bit. The stranded wires start to separate and go separate ways. They all need to go into that one hole. And if they don't, they have the possibility of contacting that other cable and bad things. Just try to be really careful about getting the whole thing in that hole, not touching anything else. Like even right now, I'm gonna unscrew the one that I did a minute ago, because I can tell it's just not in there all the way. Press it in while I turn those screws. It's about all you can ask for. And all the way to the back of the terminal block. Push it nice and hard. And then lock it down. I think that's good. We'll do the next couple. Black at the bottom, gray at the top. And these are flathead blocks. Black at the bottom. Right on top. Now, look at the board again. So it's supposed to be positive and negative. Maybe my electronics theory is backwards. I haven't done this stuff in a while. I'm going to consult the little guide here. Photo, positive on the bottom, negative on the top. And what they're doing in the video. Black on the bottom, red on top. Okay, they're doing it in the same order. That's what I see. Black on the bottom, red on top. I'm going to do it in here. It's funny how it only takes them a minute or 5 to, well, it's a 12-minute video in order to set this up. But here it's taken me, let's see, how long have I been streaming? Well, some of that's been explanation. I've been streaming for 1 hour and 60 minutes. Actually, I started the stream a little after that, so probably about an hour. The other one is also black and top. is that anyway? Okay, that's the heated bed. So honestly, polarity didn't matter all that much in this particular case. Oh, sweet! They tin these. They put lugs on, not lugs, but they tin them. They put little spade connectors here. It's going to be a super nice connection compared to the other one that we did. All right. Once black on the bottom. Start with black here. I'm going to slide both of them in at the same, because I think in this particular instance, it may actually be easier to connect them that way, because the cables are so close to one another. One where the holes are toward the top on these screw terminals. Okay. Where's that on top? I'm going to go in sideways. They can't go in sideways. Okay. But if I turn the board sideways, that worked. So the red is in, but not screwed down, and black. That just popped out. All right. So if the red is in, it's good enough for a quick screw down, so it doesn't slip out. Okay. It's got a nice connector on it, so it shouldn't move. Black bottom. Slide it. Okay, it's in there. Slide it down. Good. So make sure that that's supported enough. Whoa, jumped off my hands. It's good. Put on this torque. Yep. Cool. Okay. Four more connectors for this particular portion, which is the nail biting portion that isn't labeled correctly, or at least it isn't labeled well. I'll put it that way. It's fine, but and I can probably trace these back to where they actually lead to as far as the component, which would tell me where they would plug in. But I'd rather not have to chase that. Once again, red on top, black on the bottom. Be free. They don't come out. That's interesting. It is clicking of the end of the screw. They don't want Yeah. Guess they're wrapped around on the inside. Okay, so I got the black one out. There's the red one. They look good. Okay. I'm going to go ahead and undo the last two that are here. Those are the power supply wires. Now, this board is free. I don't think I broke anything. This JST connector is separated, but I think I can just pop that back. I don't. Yep. Oop, something came loose. Oh, just a little bit of glue. Just the last bit of glue from that connector. These JST connectors are really just hand enclosures. Pins come right up the board, and the JST connector is just a guard thing that keeps things polarized. It's a cool way to do it. Anyway, that's taken care of. So now, okay. I'm going to fast forward in the video just to make absolutely certain. Black on the bottom, red on top. Exactly right. Okay. Put the silver wires. Try to get them into an orientation where they can be plugged into the board. Wires like to interfere with that process. Top, black on the bottom. Yep. These are tinned as well. It's just the first two that aren't. All right, so let's go black. Or to get some slack so I can move it so the wires are in the way. Okay, there's black, it's red. Black, and then in there. Oh, black is not in there. What the hell, man? That shouldn't come out at all. Unless I had the wire in the wrong place somehow. All right, let's pop this back open. Okay. The manual open. My unscrew button on the screwdriver doesn't seem to be functioning completely up to snuff. A little annoying. There. And then get locked down. hold on to the thing. I really shouldn't do this late in the morning. Okay. Just test these by pulling on them a little bit. So I did before, and the black one came right out. All right, so this time the black one is staying put. That's good. Come on now, the power supply cables. Black is in the corner rather than the inside. Yep. Yep. Okay. Corner. No. Red. On the inside. No bridging, no touching. I think we have appropriate power in this board. Means that I believe the next step should be installing the board onto the standoffs with screws. So let's get all of the cables over the board where they belong. Not in the board, but just above them. So we can position the board on the standoffs. Pushing the loam back out the back side of the buttons. Just pull up one of the six. Okay, so now screw standoffs are unsigned SD card slots right there. I should have waited until after I had the board installed to install the adhesive on the drivers. I just keep knocking them off, but I'm going to ruin their adhesive. There's the tallest thing on the board. I have him to not do that. Okay. Think that is the place where it should be. So let's go ahead and try to screw this down without the aid of magnets. I just don't think I have the aid of magnets. No, I don't have the aid of magnets. So this one in the corner. Okay, got one in. Good start. Next, I'm going to do the one that's sort of in the middle-ish. Oh. Drop the screw. I'm going to torque these very tight. I'll go over them again before it's time to put this away. Just don't want the board to move around while I install some of the components. Okay, there's 3 screws. And last screw. New build surface here. Okay. Physically, the board's installed now. I know where the LCD goes. That's probably the only one off the top of my head. That's okay. We'll figure it out. All right. So going back to desktop. All right. Checking. Yep, that looks about right. Okay. So going back to this diagram that they laid out, which should be pretty easy to follow from the board itself. I just can't see any of the really, really fine silk screened imprint on the board itself. I can use my photo of the board from here, and that will take me some of the way there, but not all the way. And so the original board had driver plugs. Actually, the driver plugs are more or less in the same space. So I think that I'm going to start there. What order do they do it in their video? They plug in all of the stuff on this side first. All right. So I'm going to do the same. Okay. So starting below the blocks that we were working on, CNC fan. Is that's the yellow and blue. Should be a yellow blue cable. That's this one. CNC fan goes here. I think that's the only yellow blue cable in the bunch. I believe I identified that earlier in the stream as strange, so, and it was around that area on the main board. So just looking That says it's CNC fan, and this says fan 0, which I suppose makes some sense. And I believe it's the only controllable fan that is not the box fan, which has a separate instruction here. Well, that's always good. Please check cables before plugging in, or it may cause short circuit if cables are wrong connecting. Yeah, you think? That's why I went over those terminals really closely. Just looking for where they connected the fan for the box. Thought that it was, I guess it was here. Ah, okay. So the box fan goes opposite the drivers and right next to the CPU. So opposite the drivers, next to the CPU. Just trying to find out where that sits here. Okay, so there's that red thing. No, it's on the other side. So I guess it's that topmost block. So it looks like no, not here. I did. PTDET. Is that what that is? Just trying to figure that out. I don't think it's this one. I think it would be this one. It's right next to the CPU in line. And I think it's in line with these pins. So no, because it's a 3-pin. Whereas this is only 2-pin, so it would have to go here. Otherwise unmarked. Or is that just a flash artifact? I'm gonna grab my phone and see if I can find any writing in that here. Aha! It is labeled, in fact, fan 1. It's just blown out in that that photo, and you can barely see that the bottom one says fan 0, at least the bottom in this orientation. Okay. Yeah. So this text says fan 1 up here. It's just blown out because the flash on the photo. Okay. I'll have to remember that. That's fine. All right, so what's next? So there's fin, there's the X end stop. All right, drivers have 4, end stops have 3, 2. Of course, it's quite a simple switch. I'm losing it here. All right, so these are labeled. This one is labeled way too small to read without phone assistance. Why? So it's the Y stop, which goes here. Which is right here. That's where I put it. This one in the fiddly thing that are hard to orient so you can read them. X goes in that first one next to the fan. So read that correctly. Pop that in. Okay. Z. I'm just verifying against the big photo because it's just hard to read the board. And this is a direct photo of this particular board that I took on my desk of this board. It's one example. Otherwise, I probably wouldn't trust it as much. Okay, so Z. Z's in there. And now the 2 white ones. Those are the thermistor for the board and the thermistor for the extruder. I really wish that these were linked. They're sort of labeled. They're going into different loans. And the one that controls the heat bed is one loan. One that controls the extruder is the other. This one goes into heat bed. It's also the shortest one, so it makes sense that it would go into the closest to the loon connector. And here is the slate load 1, which just barely slots into its appropriate place as the last one on that side. Okay, so that does it for the row. We've got all of our end stops. That entire row is finished. I'd best move this so you can see easier. All right. So this is the entire row of connectors. It's all set and done. Those are the end stops. That leaves just the drivers, which also have these little yellow tags on them, which are difficult to read, although these are a little bit bigger. Okay, this is X. It's here. This is Z. Where does he go? Z goes. See, this is 20. Z goes here. Yeah. See the tapers. No, they're at the same distance. So why aren't they plugging into? Just getting a little yank. What is the one that I'm holding? Hopefully the extruder, because it's pretty darn long. No, this is Y. Y. So here. X, right? X. These things off should be an exercise in futility. Keep brushing, and they turn and slide. Last remaining one is E. Just going to verify for sanity's sake. Yep. E. Okay, it's in there. Last fan we discovered lives here in this first and second set. Yeah. So I checked and double checked everything as I installed it. There shouldn't be anything amiss. I'm just going to try to shove some of these cables back through and hopefully get some semblance of airflow. Hopefully these things is not a great time for this kind of stuff. Fine. Oh, of course, the LCD cable. The one thing that I knew where it went. Okay, plugging that in. So now everything back in its home would go to the best of my abilities. Before I put the cover on, because it's bad bad juju to put a cover on something that you just worked on. You're not absolutely certain that it works yet. We need a first boot. Anytime you change a motherboard, you always leave the case panel off before the first boot. Okay. Are we ready for this? I want a test boot, and then I want to individually heat up the hot end, heat up the heated bed, make sure those components work. And I think I can be done for today. I'm not even going to bother with a test print tonight because I'm very tired and it's way, way, way early in the morning. This went on for a little longer than I expected. All right, so the next step is to grab a power cable. Just hoping that I had one handy. I don't. At least that's what I'll get. So, use it for just a moment. I'm going to grab a power cable. And we'll try this for the first time. Sorry about that. Okay, so important notes. I'm plugging this into a surge protector that has a known good surge protector. And that surge protector is plugged into the uninterruptible power supply running the screen, a computer, etc., which has some advanced power control circuitry. If something goes super awry with this, if it is wired backwards or shorting or something to that effect, then the power will just cut safely, hopefully, and the stream will stop pretty quickly. I'll give it that. So the power supply should be off at this point. Just in case we get a hot to ground situation, I am going to insulate myself how best to do that. No, we're talking about DC 12 volts, or sorry, DC 24 volts. So it's not a whole lot of voltage. So it's not going to jump. So in this particular instance, this bag that I finished the teriyaki jerky would do the job quite well. Plastic. They should melt on them. There's the plug in here. Just don't press it. And it's on. I see a Marlin screen, which means the processor works. It says SKR Mini E3. Slide this backward. No magic smoke yet. I think you can read the display, but I basically see the Marlin firmware standard home screen. The fan on the control is spinning, which is a good sign. I get a red light on the motherboard indicating that it is online. Both thermistors are currently reading 21 degrees. The first thermistor I'm going to try to increase slowly is going to be the bed. So I'm going to set this at 50 degrees, nice low temperature. And the thermistor is responding, 24, 23, 25, 27, 33, 34. The bed is getting warmer. So I believe the thermistor is functioning correctly. Otherwise, I would be getting these increasing at all really. Not seeing any magic smoke. 38 degrees, 39, 40, 41. This bed heats excruciatingly slowly compared to the TiVo Tornado, which I've been using recently. The TiVo Tornado has an AC heated bed, which is 120 alternating current directly from the wall to the heated bed's ceramic heater. Lots of current, lots of voltage, just straight heater. All right, so this is settling at 52 degrees. I am going to have to do some PID tuning on this before I start really printing, but otherwise it's holding at 52. Feels pretty good. I'm just going to add a thermometer, man. Look at that. Oh, there it is. Oh. Fahrenheit, Celsius. And with my pretty inaccurate thermometer here, which is just an infrared thermometer, I'm getting 46 degrees, 47 degrees on the surface, which is just about right for 50 degrees. Actually, it's reading 48 degrees, 47 degrees. So the thermistor is pretty much dead on. It's doing its job really well. It's now reading 52, 49, 48, 49. So that's still within range of a couple degrees. I mean, I don't need extreme accuracy when it comes to bed heating. I'm going to go ahead and give it some juice. I'm going to turn this up to 80 degrees, which is the maximum that I usually print PLA. And that's troublesome PLA. So that's I would typically print out the maximum. So bed, it's at 50, so we're just going to go up to, you know what, let's say 90 degrees. I very rarely have it up that far. Okay. Set for 90 degrees. We're at 2. The control area is still very cool. No drivers have hit yet. 53 degrees. 54. My thermometer says 57. This is 56, 57. My thermometer says 58. So it is heating. Just heating slowly. The slowly is within spec. Has nothing to do with the control board. The Ender 3 happens to have a 24 volt bed instead of the 120 volts AC bed. I can start to smell the heated bed, just bed heater. No smoke, nothing untoward. 64 degrees. Thermistor's reading dead on. 68. I also have an air conditioner in this room, which was probably countering some of this heating. In a perfect world, closure of some kind would be more than likely beneficial. It's, I never print in one of those. It's always going to be in this particular room anyway, just in the corner over there. It is in the opposite corner from the air conditioner, though. That wasn't really on purpose, but it did turn out to be a very good idea. As you know, it's going to be the hottest corner of the room, kind of thing. It's a relatively small room anyway. The Cpgeek.org lab. But yeah, keeping it from the direct flow of air from the air conditioner is probably a good idea when printing or heating. Currently at 77 degrees, showing on the screen here, the thermistor. And my hand thermometer says 76, so it's not too bad. Just nearing the 80 degrees. Once again, I have it set for negative, so hopefully this shouldn't take too much longer. I just want to make sure that it heats up to that temperature. I usually don't print past 70, but I want to know that this print bed is good for doing things like flexible filaments and that kind of thing. I think I'm probably going to end up upgrading the extruder just a bit. It hasn't failed me in PLA, but if I'm going to be doing any sort of flexible filaments, then I will certainly need a tougher extruder and also something that does dual gears. Dual gears is going to be pretty important for that. So we'll see. I also just ordered some Capricorn tubing for both my Ender and the T-Void Tornado. Capricorn tubing, the composite of the plastic is a little bit more free flowing. The way the plastic is, it's quite a bit more slippery, which is good for this case. And it's also a little narrower, about the same diameter as filament, so that there's a little less slump. There's less foiling, springing, less necessary retractants and those sorts of things. So you could print more accurately as well. Both of these printers that I'm going to equip with Capricorn tubing. All right, we've reached 87 degrees, 88. Thermometer says 86, 85. Still not too bad. 88. 89. Thermometer says 6. Thermistor says 90 on the screen here. The thermometer that I'm holding in my hand says 87, 86. It's still not bad. I think we're close to its extent. It should be able to go up to 100. I don't really want to test it up to that much right now because it'll take a long time to get there and it's not important. What is important is that the bed, in fact, does heat up to temperature. So I'm going to go ahead and turn the bed all the way down to 0 and let it cool off while I go ahead and test the hot end. So the heat on the heated bed has been cut completely. The hot end thermistor says 32 degrees currently, 33. I think it's actually picking up some of the heat from the heated bed, uh, which isn't terrible in this instance, but we know that the thermistor works in some place. So now that that's off, I'm going to go ahead back into temperature and go to nozzle, and then I'm going to try first a low temperature, like 50 degrees. So there's 50 degrees. Part fan is in fact spinning. Oh no, that's the hot end fan that's spinning. Okay. Okay, so it immediately went up to 50 degrees, 60 degrees. Thermistor was reading 64, 65. And I told it to turn on to 50 degrees. I think maybe there's minimums for PID tuning that is quite low for a thermistor. I'm going to go ahead and just turn this up to a full normal temperature of 190 is the low end that I would go with on the nozzle for printing PLA, which is sort of the minimum stuff. 180, 190. So I'm going to say 190. And as I did that, I saw the little light go on the motherboard here, indicating that it is heating. Go back to the main screen so we can watch it heat up. It's at 71 now, 73, 76, 78. Heating up nice and fast. Just going to pull the hot heated bed underneath the hot end, just in case anything were to happen. 129. 42. Make sure the heat tip is actually doing that. It's hard to actually measure. Okay. I can try to measure a hot end in this way. The light indicating that the heater is heating is pulsing, and we're at 187, 188. The pulsing is getting wider apart. The light is not blinking. We're at 192. I guess that indicates the switching of the heater on and off with pulse width modulation, PWM control method. So we are an acceptable 190. All right, so I'm going to then raise the temperature again, and I'm going to go with, I'm going to go with, now that I know that things work and there's been no magic smoke. Menus different. Okay, so the there's a configuration menu instead of a prepare menu, which is odd, but it contains many of the same things. Oh no, that's so you can control what it does when you do those things. Interesting. All right, so motion, not configuration. Maybe I have to turn off the nozzle to get those things. Oh no, wait. Okay, so preheat PLA is with temperature. The menu is organized a little differently than I'm used to in Marlin. It's interesting. So I'm going to go ahead and preheat ABS. Use their defaults here. I'm going to preheat both for ABS. So preheat ABS. And their defaults are 240 degrees for the hot end. And currently nothing on the heated bed. That is interesting. So I'm going to go back into temperature, go back to preheat ABS, select preheat ABS bed. And no, it doesn't appear to be. If I go to the configuration editor for ABS, it has 240 and 0. It's interesting. Right? What about PLA? PLA has preheat of 185 and 45, which are kind of low for temperatures like that, I think. Before I start running the drivers, though, you know what? I'm going to do a test. Not a print test, but a driver test. I'm going to run the drivers through the motions one time completely to make sure that they're hooked up correctly and are moving in the correct direction. I'm just going to nudge each one of them in a direction and see what happens. So move axis, move X 1 millimeter to the right. And that works. Holy crap, that's silent. I do not hear these. Okay. So X moves, Y 1 millimeter forward. Okay, Y moves, Z 1 millimeter up. And Z moves. These are all silent. Okay. Where's my homing control? I cannot home separate axes. How about you give me a couple? There we go. That's filling, which is great. Now, homing. This is where things could get fun because if the end stops are not configured absolutely correctly, they could just continue to try to crash into them. So I'm going to hit home and keep my finger on the power button. So auto home and just move into the power button. Go. I can't hear these steppers whatsoever, and that freaks me out. I'm going to hear Z just a little bit. Okay. I think that's it. I'm just feeling the driver heat sinks. Feel fine. Temperature. Cool down. So the only reason that this thing is loud whatsoever is that power supply fan and the park fan, or a hot end fan, I'm sorry. So cool down is happening. 5. All right, so I'm gonna power this thing off, just so I can put this control box back together. I think that is a job well done. Seems to be working properly. Fan connector oriented underneath the. There we go. Ooh, ooh. Straight. Maybe clear out any wires up here. Where is this? Two short screws and a long screw. So, two short screws here. So I probably should have given this disclaimer at the front of the video. In fact, this is going to be in the title, but this is not a guide for doing this work. I mean, it would be good to follow along with, I guess. But I am by no means expert at doing this very clearly. Uh, if you destroy your printer by following this video, it's on you. I will go ahead and put a similar disclaimer in the title and description of this video as soon as it's available to do so. I'm done here. Screw doesn't seem to get purchased. Oh, let's pull apart this part of the case again. Not that I screwed it in very tight at all anyway. Just because I want to see what that's supposed to screw into at the back. There's that. The other parts. I guess it screws into something screwed back there. Try that first. Figure out where that's supposed to screw into. I'm going to unplug this completely. Plug it. Now that I know that it works properly. All the way around. Those are the other two screws. Where's the screw that I actually need? So, printer. Yep. Screw. Super. Nope, it's still in the hole. It's that screw that's out there. Take the lid off and see the screw hole. Okay, so it's that one there. Take it to it all. Super. All right, I gotta get my hands there. Get a magnet. This tool is going to take specifically for this. Okay. Cover me. Put her up. You. Barely. There. Ah, perfect. Gotcha. This shouldn't be that difficult. Particular screw operation. That is. Got it out just fine. I've been in here before even. I took a picture of the board before. The USB plug that fell off the board. Just started by hand, maybe? Just keep spinning on with a screw. No, still sometimes. Okay, so see if I can get some light and see the hole. The issue is that it's a slotted hole. So like it's supposed to have play to move the thing back and forth. Okay. It should be right beneath, in this orientation, the right side. And it should just go in there and screw it. But it's going everywhere but the place that it needs to go. Get it? Nope. Still off axis. So frustrating. I can do all this electronics work without any extreme fuss. I can't put a lid on a stupid electronics ones. They build it right in the extrusion. Like, it's a really dumb place to put it. see where it's supposed to go in. With and without the cover. Just will go there. Wait. I think I did it. Okay. It's about time. Let's turn this back around, get those other two screws in. And everything will be fine. I actually want to get a set of screw heads or hex screwdriver tips. There we go. Words are very helpful in trying to communicate ideas. So yeah, I want to get some hex screwdriver tips for this electric screwdriver as well for these kinds of jobs. I think that's it will help quite a bit for getting in and out of electronics cases, especially. Maybe I'm just using my manual dexterity for the day. Because that certainly happens when you're up this many hours. The time is currently 6:07 a.m. Eastern Standard Time, which happens to be where I live. As soon as I reassemble this, put it back in its perch, I'm going to bed. No. Because of that slot, I'm going to have to unscrew it slightly so that I can move it in its slot. So you can see down. Up so I can bed. I can slide that over. Tighten that back down when these are in there. Take to move. Probably do the cable stress on the inside. I also need to pay attention when I move this thing. Those heat sinks might just pop right off. I don't want to short anything out. So I got to be real gentle when I move this. think I might even invest in some thermal epoxy for those driver heat sinks. I don't really like that they pop off when you wiggle them. With the stock adhesive. I think that's my biggest gripe about this board right now is that the adhesive on the heat sinks for the drivers is not very good. And those are screwed down. Yes. Screw this the rest of the way down. So, put the SD card in there. My Allen wrench back in the box. Put my screwdriver bit back in my thing of screwdriver bits. Even the one that I damaged, it might still be useful. It's just a little port. All right. So that just about does it for tonight's stream. Once again, my name is Josh, also known as Cpgeek. I can be found, as always, at Cpgeek.org for my long-standing blog. Also, at Cpgeek.org, you'll find links to this Twitter, my Twitch, where I play games, twitch.tv/Cpgeek2. That is the number 2. You can find there's a Facebook group for Cpgeek.org where I post about random tech things as I find them, as well as videos like this. Oh, autofocus. Back it up. Sorry about that. No, I have to talk to the hand. I'm just trying to get this thing to refocus real quick. There we go. Anyhow, tons and tons of technical difficulties. Anyhow, at cpgeek.org, you'll also find the Discord link, which is a perpetual invite to the cpgeek.org Discord server, where I'm always hanging out. If you want to come by and chat, that'd be awesome. Please be sure to like, subscribe, click the bell icon. It'll let you know when I post more videos or go live again like this. So it's something I'm up to. I try to post maybe once a month or so. So please do keep that in mind. I also try to do a game stream on Twitch every week or so when I can. With work and family, it's a little difficult to find time to play games and stream, but here I am. That's why it's so late at night. Let's see what else. Oh, the link for donations is right on below in the description. If you are at all interested in contributing to this channel or any of the other things that I do on a regular basis, any amount of money would be very welcome and very appreciated. Thank you in advance if you are interested in going ahead and donating. Clicking that basically just takes you to PayPal. You can send me some cash via PayPal. And you'll be recognized on the next stream, or if you to contribute during the stream, it would pop up on stream. Either way, I am very thankful to anybody who chooses to donate. You're very generous. Thank you very much. And for those who choose to support us in other ways, just by commenting, ask any questions that you might like down below in the comments. Come on over to Discord and have a chat. You can find me on Twitter. I'm at Cpgeek, and yeah, I'd be happy to talk with you guys. Thank you very much for joining me in this endeavor. Once again, totally not a guide, but I'm quite happy the way that things turned out with the installation of this board. Everything seems to work. homing works, which means that all the drivers are plugged in correctly and the end stops work. The heaters heat up to their temperatures just fine, and I've basically can measure that externally and verify them. Um, no magic smoke, which is always a plus. I can't say that that is always the result of the projects that I take. Uh, so happy to have a decent result. And tomorrow I will begin testing this guy with some test prints. I'll probably start with the calibration cube, probably upgrade the firmware, uh, and there will likely be another stream in the very near future, maybe tomorrow, I don't know, of the installation of the BL Touch for auto bed leveling, which will definitely definitely need a firmware upgrade on this guy in order to make that go. Just because Marlin requires some different configuration for BL Touch. I do have that gear here already, so it's just a matter of finding time to make that happen. I do want to test out the printer with a print with manual leveling first. In fact, I don't believe that I've touched the leveling since I perfected it last. So I'm actually going to see if it'll just print as is. That would be super cool because bed leveling is the suck. But if it doesn't, then I'll go ahead and manually level and test it as it is, make sure things work before I move on to the next step of auto bed leveling. And be sure to tune in for that. So go ahead and subscribe and click that bell. Anyhow, it's very late. I wish you all a wonderful morning, evening, afternoon, whatever time it is that you're watching this on. I'm just